Resultant vector. Using the component method. A point P has x and y coordinates. A vector arrow has x and y components. These are px along the x-axis and py along the y-axis. You can also place py here. If you observe, it's a right triangle, so you can use the Pythagorean theorem to solve for the magnitude of p. As for direction, use the trigonometric function tangent of theta equals the length of the opposite side divided by the length of the adjacent side. Let's have an example. A train has traveled a distance of 12 kilometers west from the train station. What are the components of its displacement? We are given with d equals 12 kilometers west. We're going to find the x and y components of d. To solve, draw a vector diagram first. The x component of d or dx is negative 12 kilometers or 12 kilometers west, where the negative sign gives the direction. So dx is just equal to d. The y component or dy is 0 since no movement along the y-axis. Next example, find the x and y components of a vector f. In the vector diagram, it's shown that f is 57 degrees north of east with its x and y components fx and fy. Before we proceed, let's review our trigonometric functions SOHCAHTOA. Sine 57 degrees equals the opposite side fy divided by the hypotenuse f. Cosine 57 degrees equals the adjacent side fx divided by hypotenuse f. From these equations, we can then solve for fx and fy. Let's have our last example. Anna walks 15 meters at an angle of 25.5 degrees east of north, then another 9 meters east before she reaches the store. What is her resultant displacement? We are given with displacements d1 and d2, and we will find dr. First, we draw a vector diagram and connect displacements d1 and d2, then draw dr. Now solve the displacements d1 and d2 separately. Let's have d1, which is 25.5 degrees east of north. d1 has x and y components d1x and d1y. The angle theta is obtained by subtracting 25.5 to 90 degrees. Now we can solve for d1x and d1y. Now let's solve for the x and y components of d2 equals 9 meters east. d2x equals 9 meters. d2y equals 0 because there are no movements in the north and south direction. We can now solve for dr. It's the square root of the sum of the square of the x and y components. dr equals 20.52 meters is just a magnitude. We will use tangent of theta to find the direction. I just want to check our angle using a protractor. So our resultant displacement vector is 20.52 meters, 48.87 east of north. Why east of north? From our first displacement, it started from the east of north. Therefore, it serves as the basis for the resultant vector.